Okay, so from chapter 5.3, number 15 and 17 were requested. So they're similar, so we'll just do them in one video. It says here 4 times cos squared minus 1 equals 0. And if I'm just solving for cosine, wanting cosine to be by itself, I'm just going to move away the 4 and the 1. So I'll add 1 to both sides. We get 4 cos squared equals positive 1. And then I'll divide both sides by 4. So then we'll get cos squared equals 1/4. And still, I want cosine, not cosine squared. So I do have to square root both sides. But when we square root ourselves, we have to make sure we put the plus or minus. So square root of 1 is 1, square root of 4 is 2. So really I'm just looking for the locations where cosine is positive or negative 1/2. So if I go to my unit circle, I can say, oh, cosine is 1/2 here at 60 degrees, so pi over 3, and all the other pi over 3's, right? Anytime I'm 60 degrees above the x-axis or below the x-axis, cosine is going to be positive or negative 1/2. So we'll say that x is pi over 3. Another one will be 2 pi over 3. A third one would be 4 pi over 3. And then lastly, 5 pi over 3. But because the question asks us to solve for all solutions, we do have to add that 2 in pi, because I could go around the unit circle 2 pi times, 4 pi times, 6 pi times, and still end up at the same location. I would still get the same answer for cosine. There is a way to condense. I can kind of simplify these guys a little bit, but we'll leave it like this. This is good enough for our answers. The back of the book is going to condense it down so that you don't have these augmented answers, but we'll leave it like this. All right, and let's look at one more. So here again, I want to get sine by itself, but now I have sine squared of 2x. I can't remove the angle. This is called the argument of sine. I can't remove this. I can't remove the 2 from here. I have to just kind of leave it, but I can remove the coefficient here. So I'll divide both sides by 2, and I get sine squared still of 2x equals 1/2 now, because I divided by 2, divided by 2. And then again, I want to get rid of the squared, so I'm going to square root both sides. So now I have that sine of 2x, still 2x, equals plus or minus square root of 1 over square root of 2, which is equivalent to 1 over root 2, plus or minus still. Or if we were to rationalize the denominator, that would be square root of 2 over 2. We see this on the unit circle, but we know that this is also equivalent. So we're really looking for, when is sine, I'm going to put here sine u, equal to square root of 2 over 2. And I'm letting my 2x equal u, just so that I can make it a little bit easier. It's not necessary, but we'll do it here. So then root 2 over 2 is my 45. So if I look at the unit circle at 45 degrees, that's when sine is square root of 2 over 2. And then I want plus or minus, so that's at all my 45. So like pi over 4, 3 pi over 4, 5 pi over 4, things like that. So u is going to be, oops, I started off with 5, but let's start with pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, so then I have my solutions. I haven't put the plus 2, but I'll do that. And I also need to make sure I replace u with what it actually was. I was asked to solve for x, and I just used u substitution to make it a little easier. So let's replace u with 2x, and I have that 2x equals my pi over 4. 2x equals my 3 pi over 4. 2x equals my 5 pi over 4. And then 2x equals my 7 pi over 4. I do have to make sure I'm adding in that extra. We're talking about sine here. Sine is, the period for sine is 2 pi, so I have to make sure I'm adding in that 2 in pi to all my answers, because I want all the solutions, not just from 0 to 2 pi. I want from 0 to 4 pi and 6 pi and 7 pi and all those different places. So I have my answers, except I have 2x, so I do need to divide both sides by 2. Divide everything by 2. All right, it's getting a little crowded here, but I have now x equals pi over 4 divided by 2 is really pi over 8, and then 2 in pi divided by 2 is just in pi. And that'll happen for all of my answers. 3 pi over 4 is 3 pi over 8. And my 2n pi reduces down to just n pi. So I'll write that for all of them. 5 pi over 8 plus n pi, and 7 pi over 8 plus n pi. So these are actually my 4 solutions here. All right, so just let me know if you have other questions. If you want to see just my paperwork, that's fine. Videos of certain problems, we can do that. Or just show me what you've got and I can kind of give you a little guidance on what you're working on. All right. If I don't hear from you, I will see you guys on Wednesday morning.